Hello and welcome to another episode of Throttle Stop Garage. In today's episode, we're going to have a look at 3D scanners in your garage. Stay tuned. Alright, I don't normally do these sorts of review pieces where a company has contacted me, but in this case, Revopoint contacted me. They'd seen some of the work that I'm doing on developing the suspension for the car, and they reached out and said, hey, do you want to try one of our scanners? And I said, well, that actually would probably save me a whole bunch of time. But I said that I would give it an honest review, and today, that's the subject of this video. So we're going to have a deep dive into exactly what the 3D scanning process is going to look like for you in your garage. We're not going to do anything that's nonsense. We're going to have a look at actual car parts, real things that I need in order to get my project done. Okay, so with that, let's just have a quick look at the scanner. So welcome to the Revopoint MIRACO scanner. So this is the scanner itself. You can see it's a reasonably compact unit. It's sort of like a camera. It's a little bit wider. Plastics are nice. It's got some grippy surfaces over here. This is the 3D scanner, and you can see the business end over here. So we've got a couple of set of lenses. There's a far lens, there's depth cameras, there's near sets of lenses that have a look at things. So you can do all kinds of scanning. So when you look at the spec sheet, it's pretty impressive. So you've got the ability to add color, textures, and other things to your scans, as well as both a near mode and a far mode in order to make scanning larger and smaller objects work. The battery is an integrated thing. There's a USB-C connector on the side. There's not very many switches or dials to it. There's an on button over here. You give it a long press and on she goes. So now that it's fired up, you can see what the interface looks like. There is a start-stop button on the top. You can either use that or the screen is a touch screen. The screen also can rotate, right? It's got a pretty high quality sort of feel to the whole thing. That flips all the way up for apparently selfie mode or something, not something I'm ever going to do. No one needs to see me in 3D detail. But I have found this to be useful actually when I'm scanning the undersides of things. All right, now the software inside has been probably the biggest surprise for me. It's pretty feature rich in terms of what it does. Again, this is something that's doing structured light, so in essence, it's a photogrammetric solution for how it works. It also has the ability to track markers. So you can scan in feature mode, you can scan in marker mode. Both work fine, depending on what things are. You also have the ability to edit all of your scans online, and you can see what you're doing while you're scanning, right? So you have the ability to have a look at what you're scanning. Green, of course, means go. So there we are, looking at the front fender of my car, right? So you can scan these kinds of things. You have the ability to pause while you're scanning. That button says you're good to go, so you'd like to finish whatever it is you're scanning. And then it converts it into a model space. So you don't need a separate computer in order to process these data. You can do most of that processing right here on screen. There is also an even more fully featured software package that you can load on your computer called RevoScan. I actually really like that software, and I have used some of these sorts of things in my day-to-day life, so I have some experience doing this. But the RevoScan software it's just more fully featured than what you have here. But here you do have the ability to edit points. So you can go into the point cloud, right? So that's scan of the front fender's caught a corner of the frame. I don't want the frame. I can just go in and eliminate that. It also has a one-tap edit here where I can just push a button and it'll go ahead and figure most of it out for me based on the standard parameters. That works pretty well for the most part. I've also found that for certain things, I want to go ahead and do it myself. Now, when you are scanning with the device, and we'll go over some of this stuff later, it's important that you realize it's got the ability to pick up where things were. You also can go back. I found that to be really handy. Like if you make a mistake while you're scanning, you get things out of place, it jitters, it loses tracking. You can always go back to where you started, reverse what you just scanned, So get rid of the scanning that isn't going to work, and then go ahead and resume your scanning with confidence that it's going to work much better. All right, with that, I'm going to start explaining what the tests are. So as promised, we're going to have a look at 3 different kinds of things that I would be normally scanning in my garage, and each one of them presents a worst use case scenario for the scanner. And that's how we know that no one's, I mean, other than sending me the scanner for free, no one's paying me to tell you that anything's okay. Right, so first up is going to be a wheel bearing. So this is a wheel bearing for a Nissan 350Z. It is the basis for the suspension design that I'm going to be moving forward. And the problem with it is, it's a particularly complicated little part. It's shiny, it's machined, it's also cast, right, originally. It's got 3-dimensional, like it's literally a 3-dimensional thing. I need features on the back side, I need features on the bottom side, I need dimensions all over the place, and it's not going to want to scan this thing at all. There's a ton of detail on it, and to do the CAD work for this, not particularly easy for reasons that I'll explain in a minute. Next up is a suspension upright. So this is a medium-sized thing to scan. It's reasonably, it's not huge, it's you know, it's a good size, 60 centimeters from top to bottom sort of thing. Yeah, that's about right. And it's not going to be easy to scan either because of its complexity, right? So this is going to sit in a spot between near mode and far mode, and we'll spend quite a bit of time looking at how exactly I got that done. And the last thing we're going to look at scanning is the car fender. So I'm going to scan this whole fender. Now, this isn't a particularly easy thing for the scanner to do either, because it's smooth, it's shiny, and it's reasonably featureless, right? So it's just big expanses. Yeah, okay, so there's a curve in here, and there's a little detail at the bottom of the fender, but the rest of that fender doesn't have a whole lot of features on it. So the scanner in far mode is probably going to struggle with this a little bit. Actually, I know it struggles with this fender. So this is the upright from the 350Z. I'm not trying to copy this upright. I'm just trying to pull some features off of it. And I think it's a pretty good test of whether or not the scanner's going to work. So this is the sort of part that you get. I just ordered this off eBay. So it's a greasy, nasty part, kind of old and crusty. It came from the eastern US, so bolts aren't going to come out of it, and it's going to be kind of a nasty piece to work with, but it should be a challenge. All right, so we've got a black dust shield here for the brakes. The wheel bearing here, well, it's still a good wheel bearing. It's a rusty mess, and the rest of this, you know, torn boots and all. We'll see how she goes. We're going to hang it from the rafters here, so that I can see all sides of it. And I'm not actually expecting this to work without some significant work on the part. So I don't think there's any way the scanner is going to be able to do a part like this. It's not going to like the black. It's not going to like the geometry of it. At least it's not symmetrical. So that should work for us. And we'll see what techniques we actually need to use in order to get this to work. All right, so that screen's giving us some pretty good feedback in terms of what we're doing. When it goes green, you got to watch this bar at the top. When it goes green, that tells me it knows what it's doing. When it goes orange, that means it's not happy with itself. This is a complicated part for it to scan. A little bit of a run of luck here. Everything's going pretty well. And I just try to scan it as carefully as I can. If I start losing tracking, I always go back to an area where I know things were good. And if I know I need to move from place to place, I'm going to pause it. And I'm going to sort of shake off the muscular tension here. I'm going to get back. I can check my screens over here on the left to sort of say, all right, it's going to be able to pick up features here that I can see. So I'm going to restart it there, and I'm going to let it come in and try to pick it up. So you can see we've already ruined the scan. All right, there's no way this is going to correct itself. And these are just hard parts to scan. That was, I guess, my biggest frustration was I was watching other videos and guys aren't really showing me real world all that much. There, it sort of jumps in, gets way closer all of a sudden. And then we follow that part up. Now I know for sure it does not like this upright. And find your least greasy funnel. Alright. If I don't put that back on solidly, I'm going to end up wearing it, so I just know it. Okay. A bit of powder in there. Toss some isopropyl alcohol at it. As long as it's a pretty fluid mix, you're going to be all right. My garage smells better, I gotta say. All right. It's not bad so far. You can immediately tell, other than I'm too far away, that it likes that backing plate a lot better. Can actually see it. That's kind of important. I've never been able to successfully go around that corner, and I've tried for days. I lost tracking again. It's got it. That didn't seem like it wanted to work. I gotta find out a way to make it work.
So I was continuing to fight with the upright in the sort of vertical position, so I hung it on its side so I could scan it from edge to edge a little bit more effectively. The baby powder was working as a scanning spray, but it wasn't perfect. It wasn't too bad though. But this part, wow, it fought me a lot. Literally days worth of work to try to get this one done. So in the back of my cabinet, I have an old can of white Plastidip, and I decided to wipe the powder off and just give myself the best shot at it that I can. So I sprayed it down with the Plastidip. If I want it gone later, I can just wipe it off. And then back we go in near mode trying to get this scan done. It does not for sure like that big hole in the middle of the upright. And in near mode, what I was finding was I was collecting so much data that I was outstripping the ability of the whole system to put this thing together.
All right, it's a day later, and we're ready to go again. So what I've done here is just switched the mode from near to far. So I've figured out that I'm actually struggling to get this scanned in the near mode because of the nature of the part. So I'm pretty sure this is a good case for changing it into far mode. If I need some extra detail on the part over here, like if I need to pick up these holes more perfectly, I can just scan this area here in near mode. That's going to be fine. And I can use that for measurement. But the rest of this is just about shape. So let's see if I can, let's see if I can get this done. Anyway, you sort of have to prep yourself before you go. You have to, so what I've been doing, I've been testing this all morning just to make sure that I'm a little bit too near. So when you go to far mode, you have to be a lot further away, which makes it easier. I'm going to try to move really smoothly around the part, up and down as well, and see if I can get this done. Too close. Okay, that's pretty good. Again, pause up. Back to this position, although now I'm moving off to the side because I want to make my next move around the top here. So I start back at the holes. It'll pick the holes up again. It says I'm too far. There, good. Then I'm going to do the around the top. See how that works out. Okay, that's pretty good. Okay, happy so far. Okay, let it figure itself out. And I'll take it back to a simpler geometry. It picked it up. That's great. Okay. And with that, I think we finally have a good scan. So now we're going to go to model. I'm just going to show you how to do this. It's just easier here. There's lots of processing. I've been just using the one-tap edit. I've gone through the Fusion and the Mesh and the other things, but let's just let it work for us. I'm going to have it do it detailed. I don't care about the time. Just hit OK, and we'll come back when it's finished. All right, so it's wrapped up the processing. It took about 15 minutes thereabouts to do it. You can see the details over here on the side. And for the first time, I'm happy with this scan. This is not an easy part. Again, we're not trying to do anything that we wouldn't normally do. This is what I would normally want the scanner to do. Stitched it together just fine. We'll have to throw it up in CAD and see how the accuracy is, but I'm going to call this one good. This is fine for what I need it for sure. There, which are the date stamps and other things for the material. You can't read the text. That's not unexpected. But I think the geometry of the part would be, again, consistent with whatever it is that I'm going to need for this part. I will do a close-up scan just for giggles to see how all of that works, and we'll do that in close mode, and we'll see how she goes.
So here's that same part in RevoScan, and you can see it looks lovely. There's very few errors. I'm not too sure why I would need to go back into fine mode to adjust this. I am going to do that, though, just to show you that I'm a bit of a masochist. But all the way around, you can see the part line details and the casting. You can see the bits and pieces that I have here. So I'm very, very happy with this render.
This is near. This is far.
I'm just trying to minimize the moves that I need to make, right? Of course, I know I can get this. I have this scan already in far mode. So I'm going to practice here just for a sec. At least the scan part in the good. And trying to make sure I'm not the issue. Okay. Need to pause there just to give myself a break. See if it can work out where we are. It can. Yeah. Okay. This last little bit of scan was garbage. I can hit the back button. Try to clean it up. I'm prepared to call this a success, and a pretty big one actually, so that's great. All right, so what worked? Being super careful with everything and doing lots of pauses, letting it re-pick up the feature. Again, I've got some holes here, there, and everywhere, but I can fix those up. I'm very happy with that scan. That's just on me, right? Like, again, this thing works. It's just, I get frustrated with videos that are, I should stop saying that. I get frustrated with videos that aren't truthful, but I try not to do those things. But yeah, you can clearly see in the corner there, AL5, L11. You can see the date stamp in it. I can't zoom this thing properly. Again, this is the interface on the device, so it's not like it would be in the computer, but I can't quite pick up the date. I'm pretty close to being able to see that. Anyway, the rest of the features are rendered nicely. The surfaces are flat as they should be. Again, the machine surfaces are coming up pretty good. Some of these cast surfaces are a little bit, well, they're cast surfaces. This isn't unlike what they actually look like. There's some obvious blemishes here. So this ball joint area over here isn't great. Rotate that around. So there's just a little bit artifacty there. you know, right here on the end. I'm not worried about where I've got the hanger in it. Again, that's me, but just that little bit isn't actually there. Most of this is pretty easily tidied up in post. Again, if you're good with the CAD software, good enough to do this stuff, you're good enough to get this sorted out. Okay, so we're going to call that a major win.
And here we have the detailed scan. So this is even nicer. So I can pick up, and I've tried it in CAD. I'll show you that on the other parts here in a bit. But other than that part down by the ball joint where I had a little bit of misalignment and one or two other little hitches along the way, this was pretty dead nuts accurate too.
Okay, so for the next test, we're going to try to do the fender. So the fenders, I mean, it's reasonably complicated. If you've not seen the video or I made the carbon fiber fenders, go looking for it somewhere. I might be able to put it in there for you. Anyway, the fender we're going to do in far mode again. It does seem like you really do have to be very, very careful which mode you're in. Obviously, this is a far mode kind of thing. It's a uniform gray. I'm not going to put dots on it. And we should be able to get this fender scanned. So let's give it a try. So for this, I'm going to start actually at the bottom. It's the best way to do it, I believe. Once again, paying attention to where the scanner likes and doesn't like things is kind of important here. It's seeing lots of this really well. There, happy there. The fender's causing issues, so out has to come the dots. All right, so we're going to just place these randomly on the fender and see if this fixes up the problem. Don't know. All right, let's get this part done. It is good to do if you're going to do it this way. Not that I'm speaking from lots of experience, but if you're going to do it this way, look for the areas in your scan before that you're having issues with and chuck some dots in it. I may need a little higher density here, but so just as I'm looking at it, that's what I'm doing, right? I got to make sure that I've got about an even density of dots along the way here. Because the light on is going to really, that's going to be the secret sauce. And away we go. So when you see that scan jump like that, just stop and then wait for it to catch the fix, or it'll generate a bunch of garbage data for you and you'll have to do this all again. Let's see how we're doing. Model. Whew. Yeah. That's not bad.
For all that work on the fender, here I've dropped it in. I had to quad mesh this in order to get it, so that reduces the triangles to square points. It's a fancier process, and I got it into Fusion 360 finally. It actually looks pretty good. I mean, that fender isn't perfect, but the scan's about as good as the fender.
Now, the last part, probably the piece that took me the longest to do. Okay, so it's the wheel bearing. So this presents probably the greatest challenge for any 3D scanner that I can think of. So it's, first of all, it's a symmetrical part, doesn't like that. It's a shiny part, doesn't like that. There's symmetry everywhere on it. And the real trick here, I'm going to take these bolts out, is this bolt hole pattern. I can tell you how much time it took me to draw this in CAD without the scanner, And then we'll see what the difference really is once you learn how to do the scanning part. Again, this is the SKF one. That's the cheap one. So we're scanned the cheap one, not the really good one. The difference in the quality of these parts is really quite remarkable. And the SKF one's just gorgeous. But when I first looked at this part, I thought, oh, well, I'll pull these reference rings. This is just the tone ring on the back. I don't really need that. That's the seating ring where it'll seat into whatever the eventual upright is, right? And then it'll be affixed by those 4 bolts. I looked at the 4 bolts and I thought rectangle, 1, 2, 3, 4. Not a rectangle. You'll notice there's more here on the circle than there is here. So they're rotated. They're actually on a circle. Now, for me to figure that out, what the radius is for the circles, because they're different, and all the rest, that took quite a bit of time. First, I had to figure out I had a problem. Secondly, I had to figure out how to solve it in CAD, which wasn't easy to draw. And I just need this part so I can make the upright. I'm not doing anything else with the part. I mean, dimensionally, I need the part so I can set up the rest of the drawing to pull the geometries from it. But it doesn't want to be scanned. This, I think I took 40 takes. Not a word of a lie. 40 times before I got this right. Now, that's me learning, right? So I'm hoping I'm saving you time by saying, don't even start with a part like this. You'll never, ever get it to scan. Zero chance that it'll work. So what did I do? Same as last time. In this case, you're looking at foot spray on this part, which has worked out pretty well. I have it set up on the bench here. Just a standard Lazy Susan turntable. So that was $10. They did send me an actual little plug-in USB turntable-y thing, which again, maybe it will work, maybe it won't, with a part that's got that much mass. So I wasn't too sure about that. And then I tried any number of standoffs. You can tell that was the one I used when I sprayed the part, to get the part high enough, right, so that I could scan it. And again, having done this part 40 times, it's going to take me about 2 minutes to do this part. Only 2, which is crazy, but true. It did take hours to get to the point where I can do it in 2 minutes. You need to appreciate that if you're doing this for yourself. Now, the trick here is I need all of these faces rendered in one scan. The problem, as it was with the other part, is I can't get the bottom of this. Right, so I need to be able to scan this face because I want the register for the wheel, right, and the brake. So wheel on this, brake on that, 2 slightly different sizes. I need to know all of these dimensions for when I go to draw those parts. That's going to be important, as well as thicknesses of pieces and what I've got. So with the post registering in there, then you can see how I've got that set up so that I can actually see all the way to the bottom of that part. Okay, so with that, we'll douse the lights. Pull it. Come on, baby. Work. It's good. We're 9/10 of the way home, folks. Gotta be able to pull this last little bit. Last little bit is the top scan. And that's done it. Okay, perfect. Finally. Okay, just in the raw data, when you look at it, you know you're fine. Okay, I've only got one set of lug nuts. There's a couple little pieces here and there, whatever. There's actually a way to take care of those in here to say you're good. So you want to go into the model environment. Again, if you want to edit this stuff, it is possible. Try to give you a look here. Okay, so this is just the fused model. So in the fused model, you can start to see you've got a nice quality scan going on here. This is pretty good. Now, at this point, you can use any number of the tools to go in and do your editing. I do find this quite useful. It's reasonably intuitive. So I can pull a rectangle tool and just sort of come in. This is super hard to do with you guys there. And then just start deleting points. It's nice if you get the planes kind of flat here. It'll do a much better job. And then it gives you a little zoom window, which is super handy actually. You're coming up and you can see, you can get right up to there. Good enough. Not be a little careful because it'll pick whatever's behind it. You can also use the lasso tool if you're into roping. Western joke. Now you can see there's a few little wispy spots there. Like there's a little bit of data floating. Hey, great. It's not data, of course, it's air. Floating around there. And that's easy enough to get rid of. In the mesh, you go looking for isolation. You click detect. It finds isolated points. Ah, it worked. What do you know? Okay, so that filtered out that little floaty that we had there. So that's good. And the rest of this, honestly, I'm not too worried about it. I do have the lip. I have the 2 steps on that flange that I wanted. I've got the rest of the part rendered really nicely. And that scan, all in 10 minutes. Plus about 5 days worth of learning. So as long as you're okay with the 5 days of learning part, that's super fast.
The wheel hub was a tricky thing to scan. No word of a lie. I mean, I did do it in just a few minutes when I finally did get it finished. And this is about as good as it gets, folks. So I was super, super pleased with this. I have lots of examples of how this works, but I thought I would show off a little bit in the RevoScan software, the kinds of things that it can do that you can't do on the interface on the MIRACO scanner itself. So for example, in any of these sorts of scans, you're going to end up with holes and things that you need to fill. And that's one of the things that you can do is you can have the software, the RevoScan software, automatically extract the points, like where the holes are, just what I'm doing right now. And then once you've got those identified, you can go in and click on them and then fill them. They have 2 different methods of filling. There's lots of different ways to deal with the obvious little errors and artifacts and things that come up. But there you see I've selected a couple of little holes. I could fill that whole area between the 2 halves of the bearing. I elected not to in this example. I mean, why bother? And you can make it all completely watertight. Like you can enclose the surface, which does make the work in CAD a little bit easier moving forward. So there it is with it all filled in. Then save the model out and you can transport it into CAD. So here we are with the part that I drew in CAD, just with my calipers measuring up the part, taking all the dimensions from that part that I could. I didn't obviously get all the features. And then here's that same scan. I've just overlaid them. I indexed everything based on where the bolt holes are. And you can see how well that fits. Now, it's not completely perfect in terms of being perfectly circular, but I can tell you I can't measure what the difference is there. It's a few thousandths of an inch, maybe. I didn't bother lining up that back bolt hole pattern, but you can see just by the clocking that it's in the right place and that it's the right thickness. Again, give or take a few thousandths of an inch. Even the part line between the 2 pieces was correct.
All right, so if you've made it all the way to the end, I think you'll agree we've given the Revopoint MIRACO scanner a pretty good run through its paces. We've determined that user is a big and significant component of getting these things to work. So you're going to have to practice. Don't expect to just take it out of the box and be able to shoot and have the thing work perfectly for you. That's an unrealistic expectation of almost any tool, really, let alone a complicated tool that's trying its very hardest to work well. Give it a chance to work. You know, in some of the other videos that I've watched, people have just been, you know, either overly ebullient about the whole thing. I mean, they've just been joyful, everything's great, or they've been critical of things that really come down to the technique or the person that's running the scanner, right? So if you've got no experience doing this, you are going to have to spend the time in order to learn how it works and to optimize that. So whether it's spraying, foot powder worked great, the baby powder didn't actually work too bad considering what it was. It was necessary to pull all the parts off that upright to get it to scan properly. I can then put the parts back on it, right? I can scan them and add them back in. The fender also presented a challenge. I was able to get just a feature-based scan of the fender done. It worked fine. There also is a learning curve, not only for the use of the scanner, but then for scanning 3D parts. So after you get the mesh, which so it's going to be a triangulated mesh that you're going to get out of one of these things from the software, how do you get that into a CAD system? What do we do with it in there? Are you just using it for a reference point to put another CAD part in? Or however you're going to use it. It's not magic, and each one of those elements has its own learning curve to it, right? Each one of those is difficult. So don't expect it to be perfect. Again, the example that I used with the wheel bearing, when I first had to draw that wheel bearing, it took me 3 or 4 hours to do it in CAD. It took me 40 odd takes, so it took me probably, I think I worked on and off for 4 or 5 days to get it to work. Once I had it working, like now, I can scan it and have the entire part in my computer in 10 minutes. So I think of that as just being my time. That's my time to learn how to use it. Now I know, hey, if I have another part and I need to do it, I can bring it in here, confidently scan it. I can have it done in just a few minutes, and I can have it in my computer. I didn't imagine for a minute that it would be magic and that I would be completely free from having to do that hard work in the initial phase of learning how to work with the tool that you have in order to get this to function. Anyway, with that being said, I wanted to thank you for coming along on the video. Next up, we're going to go back into the deep dive on the suspension. We're still not done that yet. But hey, we're making progress, however slow the progress might be. Once again, thanks for watching. Keep your stick on the ice.